Okay, so we're going to take a look at section 2.3, the sine law. And just to review, when you have a right triangle, okay, that means a triangle that has 90 degrees in it, you can use SOHCAHTOA to solve for any missing sides and angles, right? So you know that sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tan of theta is opposite over adjacent. Now, you can only use these ratios when you're dealing with a right triangle. Well, what happens if you don't have a right triangle? Because SOHCAHTOA doesn't work on triangles that are not right triangles. Well, that's where the sine law comes in, and then on for section 2.4, the cosine law. So you would use the sine law and the cosine law to work with triangles that are not right triangles. Okay, so the sine law then. The sides of a triangle are proportional to the sides of the opposite angles. This is what it looks like. The sine of angle A over the side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. Or you can write it as A is to B is to C, as sine of A is to sine of B is to sine of C. So the sine law is used to find unknown sides and angles if you have one of the following two situations. So you can have two angles and one opposing side, and two sides and one opposing angle. And we'll take a look at that a little more closely on the next page. So don't lose that thought there. Okay, so let's derive the sine law. So let's say you have a triangle ABC, so here it is, and you draw an altitude AD perpendicular to BC. And this symbol, this upside down T, means perpendicular to, which means it meets at 90 degrees. So AD then is the altitude of the triangle, which just means it's the height. So we can call AD H. So what we formed are two triangles. We formed AB and D and AC and D. So in triangle ABC, let's find sine of B. So sine of B then is H over C. And if I isolate for H, okay, meaning that I should multiply both sides by C, so I can reduce the C's over here on the right, then I get that H is equal to C times sine B. And in triangle ACD, let's find sine of C, which is H over B. And if I want to isolate for H, then I would multiply both sides by B, so I can reduce the B's on the right. And that means that H is equal to B times sine C. So what I've done is I've come up with an expression for the height for both triangles ABD and ACD. Now notice that both read H equals. So what we want to do is relate these two equations because both are equal to H. So that means I can take sine of BC and make it equal to B of sine C. And as you can see, I can rewrite this. So let's take let's start by dividing both sides by sine of B. Okay, then I can reduce on the left. And let's say that I divide the right by sine of C and the left by sine of C, then I can reduce my sine C's, and as you can see, you are left with C over sine C equals B over sine B, which is here. And this is part of the sine law. Okay, so if you go back up here, okay, it's actually this part of the sine law. Okay, it's just that it's flipped, but they still are equivalent to each other. Okay, and if you draw the altitude from C and using similar steps, So what that means is if you take your triangle from here and you draw an altitude from C to AB and go through the same steps that you did up here where you had triangle ABD and ACD, then you can come up with A over sine of A equals B over sine of B. So therefore, we can just equate everything, right? A over sine A equals B over sine B equals C over sine C, or you can put sine A over A, sine B over B, and sine C over C. Okay, so the next part of